Our world, this vibrant blue marble suspended in the vast, silent expanse of space, is a place of endless wonder and profound mystery. I invite you to join me on a journey, an exploration into the very heart of our planet's most astonishing secrets. Together, we will venture to the edge of the cosmos to witness the immense cosmic threats that silently pass us by, and we will plunge into the depths of our own world to uncover its most spectacular geological wonders. This is a story of a planet that is not merely a rock, but a living, breathing entity, constantly in motion, continuously surprising us with its power and its beauty. From the silent dance of celestial bodies to the fiery breath of volcanoes, our Earth is a dynamic stage where incredible dramas unfold every single moment. We often go about our daily lives unaware of the immense forces at play, both above our heads and deep beneath our feet. Today, we will pull back the curtain on these phenomena. We will investigate the giant asteroids that narrowly miss our home, explore the hidden influence of our moon on the vast oceans, and feel the terrifying tremor of continents shifting. These are not tales of fiction, they are the raw, untamed realities of our existence. So, prepare to be amazed. Prepare to question what you think you know about the ground you walk on, and the sky you gaze upon. The planet is alive, and it is filled with surprises at every turn. From the faintest whisper from a distant galaxy to the deafening roar of the Earth tearing itself apart. Let us begin this extraordinary voyage together, and uncover the wild mysteries that make our home so truly unique and so breathtakingly alive. In the profound, silent darkness that surrounds our world, there is a constant, unseen ballet of cosmic wanderers. These are the asteroids, colossal mountains of rock and ice, remnants from the very birth of our solar system, more than 4.5 billion years ago. They travel on ancient, elliptical paths around the Sun, their journeys occasionally bringing them perilously close to our own orbital path. These are not small pebbles, but giants capable of unimaginable destruction, a stark reminder of the universe's indifference to our fragile existence. Just imagine, a rock the size of a city block, traveling at speeds that defy comprehension, tens of thousands of miles per hour. We speak of them as near misses, but in the vastness of space, near can mean millions of miles. Yet, on a cosmic scale, this is but a hair's breadth. An object named Apophis, for example, is a substantial asteroid that will pass so close in 2029 that it will be visible to the naked eye. It is a celestial spectacle, but also a sobering thought about the precariousness of our position in the cosmos. These encounters are more common than one might think. Every day, our planet is bombarded by smaller debris, most of which burns up harmlessly in our atmosphere, creating the fleeting beauty of a shooting star. But the larger ones, the planet killers, as they are sometimes called, are the focus of intense scrutiny. The impact that is thought to have wiped out the dinosaurs was caused by an asteroid estimated to be 6 miles wide. Such an event today would mean the end of civilization as we know it. So, how do we protect ourselves from such a fate? Around the globe, a network of dedicated scientists and powerful telescopes forms our planetary defense system. They are the Sentinels, tirelessly scanning the heavens, cataloging and tracking every known near-Earth object. Projects like NASA's DART mission, the Double Asteroid Redirection Test, represent our first real attempt not just to watch, but to act. It was a bold and successful experiment, proving that we can, in fact, alter the course of an asteroid. The process of detection is a monumental task. Imagine searching for a dark, non-reflective object, perhaps only a few hundred meters across, against the infinite black backdrop of space. Astronomers use sophisticated techniques, observing the faint glint of sunlight reflecting off an asteroid's surface. They take multiple images of the same patch of sky over time, looking for a tiny point of light that has moved relative to the fixed stars. Once an object is found, its journey must be meticulously calculated. Scientists use the laws of gravity and motion, penned by Newton centuries ago, to project the asteroid's path far into the future. These calculations are incredibly complex, as the gravitational pull of the Sun, Earth, and even other planets can subtly nudge the asteroid, altering its trajectory over years and decades. Precision is absolutely paramount. The challenge is that we have only discovered a fraction of the potentially hazardous asteroids that are out there. Many smaller, but still city-destroying, asteroids remain hidden in the cosmic shadows, their orbits unknown. They could emerge from the glare of the Sun, giving us little to no warning. This is why the search must be relentless, a constant vigil against a threat that is both ancient and ever-present. The DART mission was a landmark achievement. By intentionally crashing a spacecraft into the small moonlet of an asteroid, Dimorphos, scientists were able to measure a distinct change in its orbit. It was a controlled, delicate push, but it demonstrated a principle that could one day save us. It is the first step in developing a toolkit of techniques, from kinetic impactors to gravity tractors, that could be deployed to deflect a future threat. This cosmic shooting gallery is a fundamental part of our solar system's environment. The craters on the Moon are a permanent testament to this violent reality, a history book written in scars. Earth, too, bears these scars, though many have been erased by erosion and tectonic activity. The famous Barringer crater in Arizona is a relatively recent and vivid reminder of what even a medium-sized impact can do. And so, as we gaze up at the night sky, we should do so with a sense of both wonder and humility. We are inhabitants of a world that is part of a much larger, more dynamic, and sometimes dangerous, cosmic neighborhood. The silent sentinels continue their endless journey, and our own sentinels, the scientists and astronomers, continue their vital watch, standing guard over our small, precious world. Our closest celestial companion, the Moon, has captivated humanity for millennia. It has inspired poets, guided sailors, and been the subject of countless myths. But its influence extends far beyond the romantic and the mystical. The Moon exerts a powerful, tangible force upon our planet, a hidden hand that sculpts our world in profound and mysterious ways. Its most obvious effect, of course, is on the great oceans, governing the ceaseless rhythm of the tides. This gravitational pull is a delicate but immense cosmic tug-of-war. The Moon pulls on the entire Earth, but the water on the side of the Earth closest to it is pulled the strongest, creating a bulge, a high tide. Intriguingly, there is also a high tide on the opposite side of the planet. This is because the Moon pulls the solid Earth away from the water on the far side, leaving that water to bulge outwards as well. It is a twice-daily pulse that circulates the lifeblood of the oceans. These tides are not merely the gentle lapping of waves on a beach. They create powerful currents that stir the deep ocean, mixing warm surface waters with cold, nutrient-rich waters from the abyss. This process, known as tidal mixing, is crucial for marine ecosystems. It brings essential nutrients to the surface, feeding the phytoplankton that form the very base of the oceanic food chain. Without the Moon's steady pull, our oceans would be far less vibrant, less full of life. But the Moon's influence doesn't stop at the water's edge. There is growing evidence that the immense weight of tidal water, shifting across the globe, can affect the Earth's crust. Some studies suggest a correlation between the high and low points of the tide and the occurrence of small tremors along certain fault lines. The idea is that the changing stress from billions of tons of water could be the final, tiny push needed to trigger a fault that is already on the verge of slipping. Think of the life cycles of countless marine creatures, which are inextricably linked to the lunar cycle. Coral reefs, for instance, engage in mass spawning events, where entire colonies release their eggs and sperm into the water simultaneously. These events are often timed with breathtaking precision to the phases of the Moon, ensuring the greatest chance of fertilization and survival for the next generation. It is a planetary-scale reproductive strategy, orchestrated by the pale light of our satellite. Even on land, the Moon's subtle gravitational changes may have an effect. Some scientists are investigating whether the slight deformation of the Earth's crust caused by lunar gravity can influence the behavior of magma beneath volcanoes. While the connection is still a subject of research and debate, it's a fascinating possibility that the Moon could have a hand in the timing of eruptions. Another way it shapes the very geology of our world. The moon's role in stabilizing our planet's rotation is perhaps its most critical contribution to life on Earth. Our planet has a natural wobble on its axis, a bit like a spinning top. The moon's significant gravitational pull acts as a steadying anchor, preventing this wobble from becoming too extreme. Without the moon, the Earth's axial tilt could vary chaotically over long periods, leading to dramatic and unpredictable shifts in climate that would make it incredibly difficult for complex life to evolve and survive. We must also consider the moon's early history. The prevailing theory is that the moon was formed from debris ejected after a Mars-sized object collided with the early Earth. This cataclysmic event not only gave us our satellite but may have also tilted the Earth on its axis, giving us the seasons that define our year and drive the climate patterns that have shaped all life. Our world as we know it is, in many ways, a direct consequence of the moon's violent birth. The Earth's rotation is also gradually slowing down, a phenomenon known as tidal breaking. The friction created by the tides moving across the ocean floor acts as a brake on the spinning Earth. As a result, our days are slowly getting longer. Billions of years ago, a day on Earth may have been only a few hours long. At the same time, this transfer of energy is causing the moon to slowly drift away from us, at a rate of about 1.5 inches per year. So, the next time you look up at the moon, whether it's a slender crescent or a brilliant full disk, remember its hidden power. It is not just a beautiful ornament in our night sky. It is a partner in a gravitational dance that dictates the rhythm of our oceans, influences the very ground beneath our feet, stabilizes our climate, and plays a fundamental role in the story of life on Earth. It is our constant, silent, and powerful companion. We live our lives on what feels like solid, immovable ground. We build our cities, our homes, our entire civilizations on this foundation of apparent stability. Yet, this is an illusion. The surface of our planet is a mosaic of colossal, interlocking plates, known as tectonic plates, and they are in constant, albeit incredibly slow, motion. When the immense stress built up between these plates is suddenly released, the ground beneath us moves with terrifying force. This is an earthquake. These plates float upon a sea of semi-molten rock, the Earth's mantle. Driven by immense heat rising from the planet's core, convection currents in the mantle cause the plates to drift, collide, and slide past one another. The boundaries where these plates meet are the fault lines, the great geological scars that crisscross the globe. It is here, along these volatile frontiers, that the majority of the world's earthquakes occur. Imagine two gigantic slabs of rock, each the size of a continent, grinding against each other. For years, decades, or even centuries, they may be locked together by friction, unable to move. But the pressure does not cease. The underlying mantle continues to push, and strain builds up in the rock, storing an incredible amount of energy. It is like bending a stick. You can bend it for a while, but eventually, it will reach its breaking point and snap. When that breaking point is reached, the stored energy is released in an instant. It travels outwards from the point of rupture, the hypocenter, in the form of seismic waves. These waves are what we feel as the shaking of an earthquake. They ripple through the Earth's crust like waves on a pond, causing the ground to heave and roll. The power released can be thousands of times greater than that of an atomic bomb. There are different types of faults, each producing a different kind of movement. At a strike-slip fault, like the San Andreas Fault in California, the plates slide horizontally past one another. At a normal fault, one block of crust drops down relative to another. And at a thrust fault, one plate is forced up and over another. This latter type, when it occurs under the ocean, is responsible for the most devastating tsunamis. The 2004 Indian Ocean earthquake was a megathrust event. A vast section of the seafloor, hundreds of miles long, suddenly lurched upwards by as much as 60 feet. This violent displacement of water generated a series of tsunami waves that radiated across the entire ocean, bringing unimaginable destruction to coastal communities thousands of miles away. It was a brutal demonstration of how an event deep beneath the sea can have catastrophic consequences across the globe. Scientists measure the magnitude of an earthquake using the Richter scale, or, more commonly today, the moment magnitude scale. This scale is logarithmic, which means that for each whole number you go up, the ground shaking increases by a factor of 10, and the energy released increases by a factor of about 32. A magnitude 7 earthquake is therefore not just slightly worse than a magnitude 6. It is a vastly more powerful and destructive event. Predicting the exact time and place of a major earthquake remains one of the greatest challenges in science. We can identify the high-risk zones, the fault lines where stress is accumulating. We can make probabilistic forecasts, stating that there is a certain percentage chance of a large earthquake occurring in a region within a given number of years. But the precise moment of rupture remains frustratingly elusive. However, we are not powerless. Seismologists use a global network of sensors to detect the very first weaker waves, P waves, that travel from an earthquake's source. These P waves travel faster than the more destructive secondary waves, called S waves. By detecting the P waves, an early warning system can provide a precious few seconds, or perhaps even a minute, of warning before the severe shaking begins. This can be enough time to stop trains, shut down gas lines, and allow people to take cover. The Earth is constantly groaning and shifting. Millions of earthquakes occur every year, though most are far too small for us to feel. They are simply the planet's way of releasing its internal heat and stress. But the great earthquakes are a humbling reminder of the immense geological forces that are ceaselessly at work, shaping our continents, raising our mountains, and reminding us that the ground we stand on is not solid at all, but a restless, dynamic, and ever-changing surface. Beyond our solar system, in the unimaginable depths of intergalactic space, the universe is not as silent as we might believe. For decades, we have been listening, pointing vast radio telescopes towards the heavens, straining to hear signals from the cosmos. And the cosmos has begun to talk back, but in a language we do not yet understand. We are picking up strange and powerful signals, mysterious whispers from the void that challenge our understanding of physics. Among the most perplexing of these are the fast radio bursts, or FRBs. Imagine a burst of energy so powerful that in a few thousandths of a second, it releases as much energy as our sun does in several days. These are not gentle whispers. They are cataclysmic shouts from across the universe. They are detected by our radio telescopes as a brief, brilliant spike of radio waves, and then they are gone. The first FRB was discovered in 2007, hidden within archival data. For years, some astronomers wondered if they were merely glitches in the equipment or some form of local interference. But as more were detected by different observatories around the world, it became clear that these signals were truly astronomical in origin, coming from galaxies billions of light-years away. The sheer distance they travel is staggering. What could possibly create such an astonishingly powerful and fleeting blast? The theories are as exotic as the phenomenon itself. Some scientists propose they are the product of magnetars, a type of neutron star with an incredibly intense magnetic field, thousands of trillions of times stronger than Earth's. A starquake on the surface of such an object, or a sudden change in its magnetic field, could theoretically unleash the colossal energy required. Other, more speculative theories involve the collision of two neutron stars, or the final moments of a black hole, as it evaporates. And then, of course, there is the tantalizing possibility that these are not natural phenomena at all. Could they be evidence of advanced extraterrestrial technology? Perhaps the energy signature of a starfaring craft's propulsion system, or a powerful communication beacon deliberately aimed across the cosmos. What makes FRBs even more mysterious is that some of them repeat. While most are one-off events, a few sources have been observed to flash multiple times, though with no discernible pattern. This repetition makes models like colliding stars less likely, as such an event would be self-destructive. It points towards a long-lived object, like a magnetar, or something even more bizarre, as the source of these cosmic telegrams. Then there is the famous "wow" signal. Detected in 1977 by the Big Ear radio telescope in Ohio, It was a powerful, narrow-band radio signal that lasted for 72 seconds. It was so striking, so unlike any natural signal known at the time, that the astronomer who discovered it, Jerry Amon, circled it on the computer printout and wrote, "Wow." It appeared to come from the direction of the constellation Sagittarius, and perfectly matched the expected signature of an interstellar communication. The mystery of the WOW signal is that it has never been detected again. Despite countless hours spent scanning that same patch of sky with more powerful telescopes, there has been only silence. Was it a one-time message from an alien civilization? Was it a natural, but extremely rare astronomical event that we have yet to explain? Or was it something more mundane, like a signal from a terrestrial source that just happened to mimic an alien broadcast? We simply do not know. These signals are not just curiosities, they are valuable scientific tools. As a fast radio burst travels across billions of light years, its path is slightly altered by the sparse matter that exists between galaxies, the so-called cosmic web. By studying the subtle dispersion of the signal, astronomers can begin to map this invisible intergalactic medium, using FRBs as cosmic lighthouses to probe the vast empty spaces of the universe. The search continues. New telescopes like the Keim Observatory in Canada are being built specifically to hunt for FRBs. They scan huge swathes of the sky every day, detecting these bursts at an unprecedented rate. Each new detection provides another piece of the puzzle, another clue to the nature of their origin. We are living in a golden age of radio astronomy, peeling back the layers of a profound cosmic mystery, one burst at a time. As we listen, the universe whispers its secrets, and we are only just beginning to learn how to interpret them. While we look to the stars for mystery, we must not forget that our own planet is a world of breathtaking geological wonders, phenomena that prove unequivocally that our world is alive. It is not a static ball of rock, it is a dynamic, evolving system, constantly reshaping itself from within. This life force is most dramatically expressed in the form of volcanoes, geysers, and the slow, relentless dance of the tectonic plates. Volcanoes are windows into the Earth's fiery heart. They are places where molten rock, or magma, along with hot gas and ash, erupts from deep within the planet's mantle onto the surface. These are not just mountains, they are conduits of creation and destruction. The same process that can bury entire cities like Pompeii is also the process that created much of the very land we live on and the air we breathe. The magma that feeds a volcano is born from the melting of rock in the Earth's upper mantle. This molten rock is less dense than the solid rock surrounding it, so it begins to rise, collecting in vast chambers beneath the surface. As more magma accumulates, pressure builds. Eventually, that pressure becomes too great for the overlying rock to contain, and an eruption is triggered, a violent release of this immense geological tension. The style of eruption depends on the magma's composition. Magma rich in silica is thick and viscous, trapping gases and leading to explosive, violent eruptions that can hurl ash and rock for miles. In contrast, magma that is low in silica is more fluid. It allows gases to escape easily, resulting in gentler, effusive eruptions, where lava flows relatively calmly across the landscape, as we see in Hawaii. Then there are geysers, a rarer and equally spectacular phenomenon. They occur only in places where there is a unique combination of intense heat from a nearby magma chamber, a plentiful supply of groundwater, and a specific type of underground plumbing system. Water seeps deep into the ground, where it is superheated by the volcanic heat source, far above its normal boiling point. This superheated water remains liquid due to the immense pressure from the rock and water above it. However, as it continues to heat, some of it flashes into steam, expanding dramatically in volume. This expansion acts like a piston, violently ejecting the entire column of water and steam above it into the air in a spectacular, jet-like eruption. Old Faithful in Yellowstone National Park is a world-famous example of this perfect natural engine at work. Beneath all of this activity are the tectonic plates, the grand architects of our world's surface. The theory of plate tectonics revolutionized our understanding of geology. The idea that continents drift was once considered absurd, but now we have undeniable evidence. We can measure their movement with GPS, seeing continents shift by a few centimeters every year, about the same speed at which our fingernails grow. Where plates collide, mountains are born. The Himalayas, the mightiest mountain range on Earth, are the result of the Indian plate crashing into the Eurasian plate. This colossal, slow-motion collision has been going on for 50 million years, crumpling the Earth's crust and thrusting it upwards to form the roof of the world. It is a process that continues to this day, pushing the Himalayas a little higher each year. Where plates pull apart, new crust is formed. Along the mid-Atlantic ridge, a great undersea mountain range, magma constantly rises from the mantle to fill the gap, solidifying into new oceanic crust. This process, known as seafloor spreading, is like a giant conveyor belt, constantly renewing the ocean floor and pushing the continents of Europe and North America further apart. All these phenomena, the fiery volcanoes, the steaming geysers, the grinding plates, the rising mountains, are interconnected. They are all expressions of the same internal engine, the heat escaping from the Earth's core. This heat drives the convection in the mantle, which moves the plates, which in turn creates the conditions for earthquakes and volcanoes. It is one vast, intricate, and living system, a planet that is constantly building and destroying, a world forever in a state of magnificent geological flux. Our journey today has taken us from the edge of the solar system to the very core of our planet. We have witnessed the silent passage of cosmic giants and felt the ground tremble beneath our feet. It is clear that we live in a universe and on a world that are far more dynamic, more mysterious, and more alive than we can often perceive in our daily lives. The story of Earth and its place in the cosmos is a story that is still being written, with new chapters of discovery unfolding all the time. These mysteries are not just for scientists in remote observatories or geologists in the field. They belong to all of us. They are a call to our innate curiosity, a reminder that there is always more to learn, more to see, and more to understand. The world is a treasure trove of wonders, from the faintest radio signal from a distant galaxy to the intricate life cycle of coral timed to the moon. The more we look, the more we find, and the more we realize how much is still waiting to be explored. If this exploration of our world's wild mysteries has sparked your curiosity, I invite you to continue the journey with us. Please subscribe to Brightside to ensure you don't miss our future adventures into the known and unknown. And for a deeper dive, I encourage you to check out our podcast on Spotify, where we explore these topics in even greater detail. Thank you for joining me. Remember to keep looking up, keep looking down, and never stop questioning. The world is full of mysteries, and they are waiting for you.